Hello everyone, welcome back to my channel. Today in this video we are going to discuss May June 2020 series with Pure Mathematics 3 970931. So let's start. So here is the question number 1. Question number 1, find the set of values of x for which this inequality holds and give your answer in simplified exact form. So we need not to solve the answer in the decimal or in the square root. So we can see there is a power here and the power here as well. So we'll solve the equality first of all, and then we'll apply the inequality at the last. So 3 raised to the power 1 minus 2x is equal to 5x. We can see there are powers, so we'll use the log. Taking log both the side, base e, so it is ln times 2 3 times 1, 3 raised to the power 1 minus 2x is equal to ln 5 raised to the power x. So we'll use the property of product and the power here. So it is ln 2 plus 1 minus 2x ln 3 and is equal to x times ln 5. So we will simplify, we'll take the like terms one side. So we'll take ln 2 plus ln 3 is equal to x ln 5, and this is minus 2x ln 3, so this side it will become plus 2x ln 3. And now we'll take x common, we'll left with ln 5 plus 2 ln 3, so I can write it as ln 3 square, that is ln 9. Since we can write it here, 2 ln 3 will be ln 3 square by the property of log, and hence it is log ln 3. And now we'll again use the property of addition. If this is addition, so it would be ln 9 5s are 45. And here this side it becomes ln 2 into 3, 6. So ln 6 here. So at the last we'll see, since this is greater than 1, this is greater than 1, so the inequality will be as it is. So ln 6 is less than x times ln 45, or x will be greater than ln 6 over ln 45, or at the last we'll write like in this way, x is greater than ln 6 over ln 40 for this answer. And let's do the next question. Here is the second question, E part. Expand 2 minus 3x to the power minus 2 in ascending power of x up to and including the term in x square. Simplify the coefficients. So we can write it as, we know the expansion of 1 minus x to the power n. So first of all we'll convert it in this form. How we can do that? We'll take 2 common, and then we got 1 minus 3 over 2x whole to the power minus 2, which can be again written as 2 raised to the power by the property of indices, 2 raised to the power minus 2 and 1 minus 3 by 2x to the power minus 2, or it can be written as 1 over 4 times this, and the expansion of this will use the binomial expansion in this when n is not a positive integer. Here it is negative, here is a negative integer, so we'll use the property. First property is 1 plus x, n is minus 2, x is minus 3 by 2x plus n into n minus 1 over 2 factorial and minus 3 by 2x whole square. And the next terms will continue in this way, but we don't require more next term because this is till x square, including x square. So that is the last term we'll write, and rest will leave as the dots. Now it can be written as 1 by 4. I'll simplify it once again. 1 minus minus plus 3x, because 2 will be cancelled, and it is minus 2 minus 3, that is minus 6, and 2 will be cancelled, so it is minus 2 into minus 3, it is 6, by 2 it is 3, and so it become 3 times 3 by 2 squared, so 9 by 4, and x square is x square, and then the rest things will leave it. So we'll write the last answer as by multiplying 1 over 4 everywhere. 1 by 4 plus 3 by 4x plus this is 9 3 is 27, so 27 over 4 is 16, and x square. That is the answer till up to and including the term x square. So I hope it is clear. Let's do the next part of it, and here is the B part of it. State the values of x for which the expansion is valid. We know from the definition that 1 minus x raised to the power n is valid if and only if modulus x is greater than, or it can be plus also. So modulus x is less than 1. It means x should be greater than minus 1 and less than 1. So here, correct, if we compare it, so in place of x we have 3 by 2x. So modulus of this should be less than 1, or we can write it as, because 3 over 2 is a positive number, so 3 over 2 modulus x is less than 1, or the last value for set of values of x, modulus x should be less than 2 over 3 by cross multiplying this 3 by 2 to the other side. So that is the final answer. I hope it is clear. So let's do the next question. Question number 3. Express the equation this as a quadratic equation in tan theta. So here we can see tan a plus b form, a minus b form. So we will use that identity here, and we will get it as tan theta plus tan 60 over 1 minus tan theta into tan 60 is equal to 2 plus again tan 60 minus tan theta over 1 plus tan 60 into tan theta. This is the identity of tan a plus b and a minus b. We should know it. Now we'll simplify, because tan theta, tan 60 degree is root 3. So we'll use it here, and we can write it as tan theta plus root 3 over 1 minus root 3 tan theta is equal to 2 plus, and here it is root 3 minus tan theta over 1 plus root 3 into tan theta. So we can solve by, so here we'll take this whole term to the other side, and it will become tan theta plus root 3 over 1 minus root 3 tan theta minus, and when I'll take minus, so I can take it as a plus, and I'll write it as tan theta minus root 3 over 1 plus root 3 into tan theta is equal to 2. Now it is like a plus b over 1 minus root 3 tan theta and a minus b over 1 plus root 3 tan theta. So we'll take LCM, and it is a minus b, a plus b. So it is a square minus b square. So root 3 tan theta whole square, and we'll cross multiply here, and we'll get tan theta plus root 3 into this, and I'm multiplying it directly. It is tan theta plus root 3 tan square theta, because tan theta into tan theta is tan square theta, plus root 3 plus 3 tan theta from the first term, and from the second term we'll get the same thing but only with the minus here. So it is going to be tan theta into 1, it is tan theta. Tan theta minus tan theta into this minus root 3 tan square theta, and it is minus, so minus root 3 plus root 3 tan theta, and this whole is equal to 2. And we can see they are like terms and opposite signs, so these two will be cancelled. Root 3 minus root 3 will be cancelled, and there are 2 tan theta. I'll add up the like terms and I'll cross multiply it over that tan theta, and at the last it was, I have written root 3, it is going to be 3 tan theta, sorry. So it is 3 plus 3 6 plus 2 to 8 tan theta is equal to, because other things are cancelled, 2 minus this 3 tan square theta into 2, it is 6 tan square theta, and hence we can write the last answer as, I'll take the right hand side to the left hand side, it will become 6 tan square theta plus 8 tan theta minus 2 is equal to 0, or divide by 2, we'll get it as 3 tan square theta plus 4 tan theta minus 1 is equal to 0. So this is the form in the quadratic, this is the equation in the quadratic form, the quadratic in the tan theta, and that is what they have asked. And hence solve the equation. Next part is hence solve the equation. So let's solve the equation now. So we can see it is since it is a quadratic in tan theta, we can take y as tan theta, and then we'll get 3 y square plus 4y minus 1 is equal to 0. So here is the equation, quadratic equation in tan theta. So I'll take y as tan theta, and this become quadratic in y now. And now we are going to use the quadratic formula to find the value of y. Y is equal to minus b, so minus 4 plus minus b squared, that is 16, minus 4 3 are 12 into minus 1 plus 12 over 3 2 are 6. So it can be written as minus 4 plus minus 16 and 12 is 28. So 28 can be written as 4 times 7, which is 2 outside, and root 7 over 6. So which can be written as minus 2 plus minus root 7 over 3. It was not required, but I have written it. Now we'll get two values of y in terms of two values of y. One is minus 2 plus root 7 over 3, and another is y is equal to minus 2 minus root 7 tan theta from here, because y is tan theta, so tan theta is 0.215, and this tan theta is equal to minus 1.5485 and all, so it is 54858, so I can write 86. I'll take little bit bigger number so that we can get it very close. From here, this theta is tan inverse of this in degree, and this is exactly 12.1 degree. Next angle for this theta is going to be 180 plus 12.1, but since we require the solution in between 0 and 180, so we'll not consider the next one. From here, theta is equal to minus 57.147, so it is minus 57.1 degree. And the next angle, because we cannot it's not falling in the range, so it means theta, next angle we'll calculate theta is equal to 180 plus this minus 57.1 degree, which is 122.1 degree. So the solution for this equation is 12.1 degree and 9, it's not 1, it is 9, so 122.9 degree. So these are the two solutions. So we'll discuss the next 3 questions in the next video. Thank you so much.